Okay, so we're going deep today into NASA's Mars exploration program. You've sent over some excellent background information
Yep.
from Wikipedia excerpts about the program itself, its history, and some of the really wild challenges of just getting to
It
Mars.
really is.
Mhm.
What captivates me about the Mars Exploration Program,
Yeah,
or MEP as it's known, is its longevity and its strategic focus.
yeah.
It actually kicked off way back in 1993, and since then it's been this constant evolving effort to really piece together the puzzle of Mars.
So it's not just like sending up a rover every couple of years. It sounds like there's like a much bigger, longer term kind of a game plan.
It absolutely is, like
Yeah.
this carefully crafted story unfolding chapter by chapter.
Yeah.
Each mission builds upon the last and drives us closer to those big overarching goals.
Well, let's talk about this goal. I'm assuming finding like little green Martians is not at the top of the list.
Well, it's a little more nuanced than that. The
Okay.
MEP has four primary targets,
Yeah.
and they all intertwine beautifully. First, they want to nail down whether life in any form ever existed on Mars.
Yeah.
Then there's understanding the Martian climate, both past and present. That ties directly into decoding its geology,
Hmm.
the rocks, the minerals, the whole shebang.
Yeah.
And all this feeds into the ultimate goal, preparing for humans to eventually set foot on Mars.
Wow. So how do you even begin to tackle something that massive? It just sounds like this intricate web of, science and engineering.
You hit the nail on the head.
Yeah.
It takes a village, or in this case, a really smart group of scientists and engineers. That's where MEPAG comes, in Mars Exploration Program Analysis Group.
Hmm.
Think of them as the masterminds behind the curtain, constantly evaluating the science, prioritizing missions,
Right.
and making sure everything aligns with that bigger picture.
Makes sense.
Yeah.
Especially when we were talking about sending, robots millions of miles away. I mean, I can only imagine that can't be cheap.
Oh, no.
Speaking of that, just how much does it cost to send something like Curiosity to Mars?
We're talking big bucks here. Curiosity's price tag over $2.5 billion. And when we start talking about a sample return mission, which is definitely on the horizon,
Yeah.
that cost could easily double or even triple.
Wow. That is just mind-boggling.
Yeah.
But I guess it makes sense given just the sheer complexity of these missions.
Exactly. It's not just about building a rover that can survive on Mars.
Yeah.
It's about developing the technology to launch it, land it, safely operate it remotely, and collect that valuable data.
Mm.
It's just this massive collaborative effort,
Right.
and those costs add up quickly.
Yeah. So let's zoom back in on that first goal that we talked about, figuring out if life ever existed on Mars. I mean, this feels like something straight out of a sci-fi movie.
It does.
Like, how do scientists even approach something like that?
Well, it all starts with a simple yet powerful strategy. Follow the water.
Follow the water.
Think about it.
Okay.
Every form of life we know of needs water to survive. So if we want to find evidence of past life on Mars, we need to look for signs of where water once existed.
So it's kind of like a cosmic treasure hunt with water as the ultimate prize.
In a way, yes. But it's not just about finding puddles on the surface. Because Mars is a very different place today than it was billions of years ago.
Right.
We're talking about searching for evidence of ancient lakes, rivers, even oceans that may have once existed.
So they're really looking for these clues in the rocks, the landscape, maybe even underground.
Precisely. And it's not just about finding water itself.
Oh, yeah.
We're looking for signs of what that water might have left behind. Things like specific minerals, rock formations, even the chemical signatures of past life.
That makes sense. It's kind of like this detective story piecing together clues from this Martian past. But you know what? If we don't find fossilized Martian fish or anything, does that mean that life never existed there?
Not necessarily.
Right.
Remember, we're looking for any kind of life, not just complex organisms like animals. We're talking about the possibility of microbial life, tiny organisms that might have thrived in Martian environments billions of years ago.
Oh, so even like a tiny speck of bacteria could, rewrite the history books. That's just incredible.
Exactly.
Yeah.
And that's why this search for life isn't just about finding fossilized microbes, although that would be amazing.
Yeah.
It's about understanding the conditions that make life possible in the first place.
All right, so we're looking for water, but what else do scientists need to find to prove that Mars could have supported life?
Energy sources are a big one.
Okay.
Life needs energy to survive, and on Earth, that often comes from sunlight. But Mars is farther from the sun,
Okay.
so scientists are looking for other potential energy sources,
Hmm.
like geothermal activity or chemical reactions in the rocks.
So Martian life might not have let anything like life on Earth.
That's a real possibility.
Wow.
We might find life forms that have adapted to thrive
Yeah.
in conditions we can barely even imagine.
Yeah.
And that's what makes this search so exciting.
Right.
We're pushing the boundaries of what we know about life itself.
Okay, so I'm starting to get this follow the water strategy, but like, how do you actually find this stuff? Is it like sending a robot with a metal detector, searching for buried treasure?
It's a bit more sophisticated than that. Yeah. But the analogy isn't too far off. Our robotic explorers are equipped with these incredible instruments that can analyze rock, soil, even the atmosphere, looking for those telltale signs of water and the building blocks of life.
So each rover or lander is like a mobile laboratory packed with cutting-edge technology.
Exactly.
That's wild.
And the technology is constantly evolving,
Yeah.
allowing us to probe deeper and ask more sophisticated questions.
Speaking of sophisticated questions, I'm curious about something you mentioned earlier, carbonates.
Yeah.
Why are those so important in the search for life on Mars?
Carbonates are like a fingerprint of past life, at least here on Earth.
Okay.
They form when carbon dioxide from the atmosphere dissolves in water and reacts with rocks. And guess what? Life as we know it is carbon-based.
So finding carbonates on Mars could indicate that there was once a lot of liquid water and potentially a carbon-rich environment where life could have thrived.
Exactly. It's a tantalizing clue that keeps scientists coming back for more.
That's fascinating. But I'm guessing it's not all smooth sailing. The challenges section in this material talks about, Mars being a pretty hostile place for spacecraft.
Oh, absolutely. Landing anything on Mars is a nail-biting affair.
I can only imagine.
It's like trying to thread a needle while riding a roller coaster blindfolded.
Okay, I am getting some serious anxiety just imagining that. What makes it so hard?
Well, it boils down to three major headaches.
Okay.
First, Mars has this ridiculously thin atmosphere compared to Earth's.
Right.
That means spacecraft come screaming in at these incredibly high speeds, and they risk burning up on entry.
Yeah. Okay, that sounds terrifying. What about parachutes? Don't they use those to, kind of slow things down?
They do, but it's not as simple as it sounds.
Yeah.
With such a thin atmosphere, parachutes aren't as effective. And then there's the Martian dust.
Oh, right.
Those notorious dust storms can whip up in an instant
Yeah.
and change atmospheric density, making landing even more unpredictable.
So we're dealing with a super thin atmosphere, potential dust storms.
Yeah.
What's that third challenge?
The Martian terrain itself is a nightmare.
Right.
We're talking craters, canyons, mountains, fields of boulders. Landing a spacecraft safely in that environment is a monumental task.
It's like trying to land a plane in the middle of the Grand Canyon during a sandstorm.
That's a pretty good analogy.
Mm.
And remember, we can't exactly send a scout team ahead of time to clear a landing zone.
Right.
We're relying on orbital images to choose landing sites. And even the best images can only see objects down to a certain size.
So there's always a risk of hitting something unexpected.
Unfortunately, yes.
Sure.
And let's not forget about the psychological pressure on the engineers and scientists back on Earth.
Right.
They've poured years of their lives into these missions, and that moment of landing is pure tension.
Yeah, I can't even imagine.
Yeah.
And all of this has to be tested beforehand, right? I mean, I bet trying to recreate Mars here on Earth is just, a logistical and financial nightmare.
You're absolutely right. Testing is crucial, but it's incredibly difficult and expensive. We're talking about building massive chambers that simulate the Martian atmosphere and temperature, developing specialized robots that can operate in those conditions,
Yeah.
and running countless simulations to make sure everything works perfectly.
It's like they're building a mini Mars right here on Earth.
It's not far off.
Right.
And every time we encounter a problem during testing, it means going back to the drawing board, redesigning, rebuilding, and retesting. It's a constant cycle of innovation and problem solving.
So let's talk about that innovation. I'm really intrigued by this Mars Scout program that started in the early 2000s.
Yeah.
Can you tell us a bit more about that?
The Mars Scout program was a brilliant initiative born out of a need to do more with less.
Okay.
NASA wanted to explore Mars in new and innovative ways, but they couldn't keep throwing billions of dollars at every mission.
Right.
So it was all about being creative with a limited budget.
Okay.
They challenged scientists and engineers to come up with smaller, less expensive missions that could still make groundbreaking discoveries. The budget cap for each Mars Scout mission was set at a relatively modest $485 million.
Wow, that is a huge difference compared to something like Curiosity.
It is. And that forced everyone to think outside the box, to come up with clever solutions and innovative designs that could accomplish big goals without breaking the bank.
So how did they decide which missions to choose? Was it like a science fair competition?
It was a rigorous selection process
Yeah.
with Dozens of proposals vying for that limited funding.
Yeah.
Scientists and engineers from all over the world submitted their ideas, and a panel of experts evaluated them based on their scientific merit, feasibility, and, of course, cost-effectiveness.
And the first winner of this cosmic science fair was the Phoenix lander, right?
That's right. Phoenix landed near the Martian North Pole in 2008. And it was actually built for a different mission, the canceled Mars Surveyor 2001.
Oh, wow.
But instead of scrapping the lander entirely, they repurposed it for the Mars Scout program, a testament to their commitment to maximizing every resource.
That's a great example of ingenuity. But what about some of those other proposals that didn't make the cut? Were there any particularly wild or ambitious ideas that didn't get funded?
Oh, absolutely.
Yeah.
There was no shortage of audacious ideas in the mix. Remember the 3 other finalists for the first Mars Scout mission?
Fill me in.
Well, there was Marvel, an orbiter designed to study volcanic activity on Mars and analyze the composition of the atmosphere.
Yeah.
Then there was S-Key, which stood for Sample Collection for Investigation of Mars.
Okay.
This mission would have flown through the Martian atmosphere using aerogel to capture dust particles and bring them back to Earth.
Talk about thinking outside the box.
Right.
What's the third finalist?
The third one was perhaps the most ambitious of all ARES, which stood for Aerial Regional Scale Environmental Survey.
Okay.
It was basically a Mars airplane.
Wait, they wanted to send an airplane to Mars. Serious?
Yep, totally serious. The idea was to have this lightweight airplane soar through the Martian atmosphere, taking high-resolution images of the surface and analyzing the atmosphere in detail.
That would have been absolutely groundbreaking. Why didn't they choose that one? I mean, a Mars airplane is way cooler than a lander, right?
It's definitely had a certain wow factor. But remember, this was the Mars Scout program with a strong emphasis on cost-effectiveness. As cool as the Ares concept was, it also presented significant engineering challenges.
Right.
And ultimately proved to be too expensive within the program's budget constraints.
Ah, so sometimes practicality trumps coolness, even in space exploration.
That's right. But the ARES proposal really demonstrates the kind of innovative thinking that the Mars Scout program was designed to foster.
I'm seeing a pattern here. We've got this long-term Mars exploration program carefully planned out by MEPAG, but then they introduced this Mars Scout program to kind of shake things up and encourage outside-the-box thinking.
That's a great observation. The Mars Scout program was a way to inject some fresh energy and new perspectives into the overall Mars exploration strategy.
Yeah.
It was about taking calculated risks, embracing innovation, and seeing what's possible when you push the boundaries.
And the second Mars Scout mission was MAVN, right? An orbiter focused on the Martian atmosphere.
You got it. MAVEN launched in 2013 and is still operating today, diligently studying the Martian atmosphere and trying to unravel the mystery of how Mars lost its atmosphere over billions of years.
So each Mars Scout mission brought something unique to the table, expanding our knowledge of the red planet in different ways.
Yep.
But what eventually happened to the program? Did it just kind of fade away?
Well, it actually went through a bit of a transformation. After just 2 selections, Phoenix and MAVEN NASA decided to merge the Mars Scout program with the Discovery program, which they rescoped to include missions to Mars.
So instead of having 2 separate programs, they kind of combined them into one.
Exactly. It was a way to streamline things to create a more unified approach to exploring the solar system, including Mars.
That makes sense. But it also seems like there were some tough times for the Mars program in the 2010s. The material mentions some major budget cuts. That must have been a real blow.
Oh, absolutely. In 2013, NASA's Planetary Science Division faced a significant budget reduction, a whopping $300 million less than they were hoping for.
Ouch, that's a lot of money. What kind of impact did that have on the Mars program?
It forced some tough decisions. They had to cancel their participation in the European Space Agency's ExoMars program, which was a major collaboration aimed at searching for signs of life on Mars.
So even with all the careful planning and, these strategic roadmaps, sometimes real-world constraints, throw a wrench in the works.
Unfortunately, that's the reality of space exploration. It's a delicate balance between scientific ambition, technological capabilities, and yes, financial realities.
So what happened after those budget cuts? Did they just scrap all their future Mars plans and, call it a day?
Not at all. They adapted as they always do.
Okay.
In the face of these financial challenges, they formed the Mars Program Planning Group, or MPPG.
What was their mission?
To chart a course for the future of Mars exploration, but with limited resources. It was like playing a cosmic game of chess, trying to figure out the most strategic moves with fewer pieces on the board.
Sounds like a daunting task. What kind of options were they considering?
They had a lot of ideas on the table. There was talk of sending a mission to analyze the Martian soil in situ, meaning right there on the surface.
Okay.
Another idea involves sending a probe to study the deep interior of Mars, which could reveal a lot about the planet's formation and evolution.
So they were still aiming high, even with a tighter budget.
Absolutely.
Why?
But the ultimate prize, the one that kept coming up in discussions,
Yeah.
was a sample return mission.
Ah, that's right. The holy grail of Mars exploration, bringing a piece of the red planet back to Earth.
Exactly. But it was a risky proposition, considering the cost and complexity. They knew it wouldn't be easy, but the potential rewards were enormous.
So did the MPPG ultimately recommend going for the sample return mission despite all those challenges?
They did. It was a bold decision, a testament to their belief in the scientific value and the long-term importance of understanding Mars.
So it sounds like we're on a path to bring a piece of Mars back to Earth. That's incredible. But what exactly would we do with a Martian sample? I mean, it's not like we can just, put it on display in a museum, right?
Well, we could, but that would be a massive understatement of its scientific value. Imagine having a piece of Mars right here on Earth in our laboratories where we can analyze it with instruments far more sophisticated than anything we can send to Mars.
Right. It would be like unlocking this treasure chest of information, wouldn't it?
Exactly. We could study its composition in detail,
Yeah.
look for signs of past life, understand the history of water on Mars, and so much more. It would be a game changer for our understanding of the red planet.
That's mind-blowing. But before we get too excited about the future, let's take a step back and delve into the missions that paved the way for these ambitious goals.
Great idea. Each mission, whether successful or not, has contributed valuable pieces to the Mars puzzle, helping us refine our strategies and push the boundaries of what's possible.
All right, so let's rewind the clock and explore the history of Mars exploration, starting with some of those early missions that laid the groundwork for everything that came after.
That's where things get really interesting. We'll uncover the stories of robotic pioneers, daring missions, and the triumphs and setbacks that have shaped our understanding of the red planet. I think before we jump into specific missions, it's important to remember that Mars exploration wasn't always, this sophisticated, multifaceted program.
Yeah.
The early days were marked by, a lot of trial and error, even heartbreak.
Oh, you're talking about those missions in the late 90s. I remember reading about those. It felt like every time we sent something to Mars, it either got lost or it crashed.
It was a tough time for the Mars program, no doubt about it.
Yeah.
But those setbacks taught valuable lessons,
Yeah.
lessons that shaped the program's evolution.
Okay, so let's rewind the clock. Where does our story begin?
Well, one of the true pioneers was the Mars Global Surveyor, launched back in 1996.
Yeah.
It orbited Mars for almost a decade,
Wow.
meticulously mapping the planet and giving us our first comprehensive view of its surface.
A decade in orbit. That's a pretty impressive run, especially considering how young the technology was back then.
It was a workhorse, that's for sure. And just a month after the Mars Global Surveyor launched, we had another exciting mission, Mars Pathfinder. It carried the Sojourner rover, this tiny, adorable little robot that really captured everyone's imagination.
Sojourner, I remember seeing those pictures. It looked like a toy car exploring another planet. What was its main mission?
Sojourner's primary goal was to demonstrate that we could actually land and operate a rover on Mars.
Okay.
It was a test of technology, a proof of concept, and it exceeded everyone's expectations.
So even though it was small and relatively simple, it kind of paved the way for the larger, more sophisticated rovers we have today.
Absolutely. Sojourner was a trailblazer, proving that we could explore the Martian surface up close and personal.
And then came the Mars Surveyor 98 program. That's when things took a turn for the worse, right?
Yes, unfortunately, the Mars Climate Orbiter, which is supposed to study the Martian atmosphere and climate, was lost on arrival. A heartbreaking failure.
Yeah.
That turned out to be caused by a simple but devastating navigation error.
A navigation error? What happened?
Okay. It's a cautionary tale of units. One team used metric units, the other used imperial. This seemingly small discrepancy led to the spacecraft entering the Martian atmosphere at the wrong angle and disintegrating.
Wow. A tiny mistake with huge consequences. What a tragic loss. And didn't they lose another spacecraft that same year?
They did. The Mars Polar Lander, also part of the 98 program, failed during its landing attempt. The exact cause is still debated, but it's believed that a software glitch might have triggered the engines to shut down prematurely.
So it must have been a crushing blow for the Mars program, losing 2 missions back to back.
It was a devastating time, no doubt about it.
Yeah.
But what's remarkable is that NASA didn't give up. They learned from those failures, they implemented changes, and they came back stronger.
That resilience is inspiring. So what happened next? How did they bounce back from those setbacks?
So they took a step back, they analyzed what went wrong, they redesigned their systems and processes, and they doubled down on testing and redundancy.
Okay.
And in 2001, they launched 2001 Mars Odyssey, an orbiter that's still operating today.
Still operating, seriously. That's over 2 decades in space. What's its mission?
Odyssey is a multi-talented spacecraft.
Wow.
It's been mapping the Martian surface in detail, studying its composition, searching for water and ice, and even relaying data from other Mars missions back to Earth.
So it's like the ultimate utility player of Mars exploration, and didn't it play a role in choosing landing sites for later missions?
You bet, Odyssey's data helped pinpoint safe and scientifically interesting landing sites for rovers like Spirit Opportunity and Curiosity.
Speaking of those rovers, I mean, they really captured the public's imagination, didn't they? Those twin explorers, Spirit and Opportunity roaming around Mars, sending back those incredible images.
They were superstars. Landing on opposite sides of Mars in 2004, they found evidence of past liquid water, a major discovery that shifted our understanding of the red planet.
Wow.
And they kept going and going, exceeding their mission lifetimes by years.
Especially Opportunity, right? I remember reading that it lasted much longer than anyone expected.
It was a true marathon runner. Opportunity was originally designed for a 90-day mission, but it ended up exploring Mars for over 14 years.
Wow.
It was an incredible feat of engineering and a testament to the team's dedication.
What an amazing story. It makes you wonder, what was it like for the scientists and engineers, knowing that their creation was out there on another planet making these incredible discoveries?
It must have been exhilarating. Imagine being able to control a robot on another planet, to see the Martian landscape through its eyes, to make discoveries that no one had ever made before.
Yeah, that's the stuff of dreams. But sadly, Opportunity's mission eventually came to an end.
It did in 2018. A massive dust storm engulfed the planet, blocking sunlight and depriving Opportunity of the solar power it needed to survive. It was a poignant reminder of the harsh realities of exploring Mars.
But even in its demise, it provided valuable data, right? About Martian dust storms and the challenges of operating on a planet so far away.
Absolutely.
Okay.
Every mission, whether it ends in triumph or tragedy, contributes to our knowledge and helps us prepare for future explorations.
Speaking of preparation, there was another orbiter launched around that time, right? The Mars Reconnaissance Orbiter, or MRO.
Yeah.
What was its role?
MRO launched in 2005, and it's still up there orbiting Mars
Mhm.
and sending back incredible data. It carries the most powerful camera ever sent to Mars,
Wow.
capable of capturing images so detailed that we can see objects the size of a dinner table.
Wow. So we can see individual rocks and boulders on the surface?
We can.
Wow.
And that level of detail is crucial for choosing safe landing sites for future missions. MRO is like our scout in the Martian sky, helping us map the terrain, identify potential hazards, and pinpoint the most scientifically interesting locations.
So it's not just about pretty pictures. MRO is providing critical data that informs the entire Mars exploration program.
Exactly. It's a prime example of how different missions work together, how orbiters, landers, and rovers all contribute to the bigger picture.
And then in 2008, we had the first successful Mars Scout mission, Phoenix, touching down near the Martian North Pole. What was special about this mission?
Phoenix was specifically designed to study the Martian polar ice caps and search for signs of past habitable environments. Remember the follow the water strategy?
Yeah.
Well, Phoenix took that strategy to the next level, landing in a region where water ice was thought to be just below the surface.
And it found water ice, right? That must have been a huge moment.
Phoenix confirmed the presence of water ice just below the surface, a major finding that fueled the hopes of finding evidence of past life on Mars. And it also made another intriguing discovery: perchlorate salts in the Martian soil.
Perchlorate salts. I don't remember reading about that.
Yeah.
What are they and why are they significant?
Perchlorates are a type of salt that contain chlorine and oxygen.
Okay.
Now, here's where it gets interesting. Some types of microbes on Earth actually use perchlorates for energy. So the discovery of perchlorates on Mars raised the possibility that similar microbes might have existed there too, perhaps even using those salts as a source of energy.
Wow. So even though they didn't find direct evidence of life, Phoenix uncovered a potential energy source for Martian microbes? That's a pretty big deal.
It was a tantalizing clue, a hint that Mars might have been a more hospitable place for life than we previously thought.
So we've got orbiters mapping the planet landers, digging into the soil, and then in 2012, we have the grand arrival of Curiosity, the biggest, baddest rover to ever grace the Martian surface.
Curiosity was a game changer. It's about the size of a small car, packed with sophisticated instruments and designed to explore Gale Crater, a massive impact crater thought to have once held a lake.
I remember seeing those first images from Curiosity. It was like watching a high-definition movie unfolding on another planet.
The images were stunning, and the science was even more impressive. Curiosity found evidence of ancient stream beds indicating that liquid water flowed on the surface of Mars for extended period. It also detected organic molecules, the building blocks of life in the Martian soil.
So Curiosity was finding more and more evidence to support the idea that Mars could have been habitable in the past.
Exactly. It was building upon the discoveries of previous missions, adding more pieces to the puzzle, and painting a picture of a Mars that was once a much warmer, wetter, and potentially life-friendly place.
And then there's MAVEN, the second successful Mars Scout mission launched in 2013 to study the Martian atmosphere.
MAVEN is like a detective trying to piece together clues about how Mars lost its atmosphere over billions of years. Remember, Mars used to have a much thicker atmosphere, which would have allowed liquid water to exist on the surface?
Right.
But today, it's incredibly thin and can't support liquid water.
So MAVEN is trying to figure out what happened to that lost atmosphere.
Exactly. And its findings have been fascinating. It's shown that the Martian atmosphere is being stripped away by the solar wind, a stream of charged particles from the sun. Over billions of years, this process has gradually eroded the Martian atmosphere, transforming it from a potentially life-supporting environment to the cold, dry world we see today.
It's a reminder of how dynamic planets are, how they change over time, and how even seemingly small forces like the solar wind can have dramatic effects over billions of years.
It's a humbling perspective, isn't it? And it makes you wonder about the fate of our own planet.
Okay, let's keep moving forward in our Martian timeline. What came after Curiosity and AVAN?
Well, in 2018, we had the arrival of InSight, a lander, with a very specific mission to study the interior of Mars.
The interior? Why focus on that? I thought the main goal was to search for signs of past life on the surface.
That's true. But understanding the interior of Mars is crucial for understanding the planet as a whole. InSight was equipped with a seismometer, the first ever deployed on another planet, to listen for Marsquakes.
Marsquakes. So like earthquakes, but on Mars.
Exactly. By studying the seismic waves generated by Marsquakes, scientists can learn about the internal structure of the planet, its crust mantle and core. They can also learn about the planet's heat flow, which tells us about its geological activity and its evolution over time.
So InSight was like a planetary doctor giving Mars an ultrasound to see what's going on inside.
That's a great analogy. And its findings have been groundbreaking, providing new insights into the formation of rocky planets, including our own Earth.
I'm starting to see how all these missions connect, how each one contributes to our understanding of Mars in different but ultimately complementary ways. It's like putting together a giant jigsaw puzzle, one piece at a time.
It's a beautiful analogy. And the puzzle is still far from complete, but we're making progress with every mission, with every discovery, with every challenge we overcome.
And speaking of challenges overcome, we can't forget about the most recent mission, Mars 2020, which landed the Perseverance rover and the Ingenuity helicopter in Jezero Crater.
Perseverance and Ingenuity. A dynamic duo that pushed the boundaries of what's possible on Mars.
Perseverance is like Curiosity's bigger, bolder cousin, right? Packed with even more advanced instruments and tasked with an even more ambitious mission.
That's right. Perseverance is searching for signs of ancient life in Jezero Crater, a location that scientists believe was once a lake. It's collecting rock and soil samples that will eventually be brought back to Earth by a future mission, the first time we'll ever have pristine Martian material to study in our labs.
Talk about a game changer. And what about Ingenuity, the little helicopter that could...
Ingenuity made history as the first powered aircraft to fly on another planet. It was a technological marvel, demonstrating that we can explore Mars not just on the ground, but also in the air.
I remember watching those videos of Ingenuity hovering above the Martian surface. It felt like a scene from a science fiction movie.
It was a remarkable achievement, opening up new possibilities for future exploration. Imagine swarms of drones exploring Martian canyons, caves, and even the polar ice caps. The possibilities are endless.
All right, we've covered a lot of ground here. Orbiters, landers, rovers, even a helicopter. But with all this focus on the past, I'm curious, what does the future hold for Mars exploration? What's next on the horizon?
The future is brimming with exciting possibilities.
Yeah, it's incredible to think how far we've come in just a few decades, from those early kind of tentative steps to these sophisticated missions we have today.
It really is.
Yeah.
Yeah.
But let's talk about that sample return mission you mentioned earlier that feels like a whole other level of complexity and ambition.
It is, without a doubt. Remember all those challenges we talked about?
Yeah.
The thin atmosphere, the treacherous terrain, the astronomical testing costs.
Right.
Well, those are all amplified tenfold for a sample return mission. It's not just about landing something safely on Mars. It's about launching something back into space from another planet.
Yeah, that sounds mind-bogglingly difficult. How do you even begin to approach something like that?
Well, it's a multi-step process, a delicate ballet of robotics and engineering.
Okay.
First, you need a rover, like Perseverance, that can collect and cache those precious samples.
Okay.
Then you need another mission to land on Mars, retrieve those samples from wherever they're stored, and launch them into orbit around Mars.
Wait, so it's not just one mission, it's like a relay race with multiple spacecraft kind of passing the baton.
Exactly.
Yeah.
And then you need a third spacecraft orbiting Mars, waiting to rendezvous with that sample container and bring it safely back to Earth.
Wow.
It's a complex choreography with no room for error.
Okay, I'm starting to understand the logistical challenges here, but let's break it down step by step. First, landing that sample retrieval spacecraft. How do they ensure that, it doesn't go splat on the surface like some of those early missions?
Well, that thin Martian atmosphere is a constant headache.
Right.
But we've learned a lot from past missions. It's all about slowing down enough before you hit the ground.
Right.
Heat shields to protect against the scorching heat of entry parachutes, to increase drag, and retro rockets firing in perfect sequence to provide that soft touchdown.
It sounds like landing a feather on a trampoline during a windstorm. But even if they land safely, what about those Martian dust storms? Don't those pose a risk to the spacecraft?
They do. Martian dust storms can whip up in an instant, enveloping the entire planet and reducing visibility to near zero. It's like trying to navigate through a thick fog, but with the added danger of, abrasive dust particles that can damage sensitive equipment.
So they have to design spacecraft that can actually withstand those extreme conditions.
Absolutely. They're constantly refining materials and designs to make spacecraft more robust and resilient.
Yeah.
For a sample return mission, they'll need a spacecraft that can not only survive a dust storm, but also operate effectively in those conditions.
Okay, so let's say they've landed safely. They've retrieved those samples.
Yep.
How do they launch those samples into orbit around Mars? Don't they need like a massive rocket for that?
They do, but remember, we're not talking about launching from Earth with its strong gravity.
Right.
Mars has much weaker gravity, which makes launching to orbit a bit easier.
That makes sense, but it still sounds like a monumental task.
It is. They'll need to develop a specialized launch vehicle,
Yeah.
something small enough to fit on that sample retrieval lander, but powerful enough to send that precious cargo into orbit.
And then there's the rendezvous with the Earth return orbiter. I imagine that's like threading a needle in space.
It's a delicate maneuver requiring precise timing and navigation. The two spacecraft have to be in exactly the right place at exactly the right time, traveling at exactly the right speed. It's really a testament to the incredible precision of modern spaceflight.
And all of this has to be tested beforehand, right? How on Earth do they simulate something as complex as a sample return mission?
Well, it's a massive undertaking involving a combination of approaches. They conduct extensive ground-based testing using specialized chambers that replicate the Martian environment, the thin atmosphere, the temperature extremes, the dust.
So they're basically building mini Mars environments here on Earth.
That's a good way to put it. And they're also developing sophisticated computer models and simulations to predict how the spacecraft will behave on Mars and during the various stages of the sample return mission.
It's like they're creating a virtual Mars to test out all the different scenarios and make sure everything works perfectly.
It's a testament to the ingenuity and dedication of the scientists and engineers involved. They're constantly pushing the boundaries of what's possible, constantly innovating and problem-solving to make this incredible mission a reality.
So we've talked about, the logistical challenges, the technical marvels.
Yeah.
But let's step back for a moment. What does this all mean for us, back here on Earth? Why should we care about bringing back, a few rocks from Mars?
It's a question that goes to the heart of why we explore space in the first place. Mars is our closest planetary neighbor, a world that might have once harbored life, a world that holds clues to the origins and evolution of our solar system.
So it's not just about the rocks themselves, it's about the stories they tell, the secrets they hold.
Exactly. Imagine holding a piece of Mars in your hand, a piece of another world that has traveled millions of miles through space and time. It's a connection to something bigger than ourselves, a reminder of our place in the vastness of the cosmos.
And from a purely scientific perspective, what could we learn from studying those samples?
Well, the possibilities are endless. We could analyze the composition of Martian rocks in exquisite detail, searching for signs of past life, studying the history of water on Mars, and understanding the geological processes that have shaped the planet over billions of years.
It would be like unlocking a treasure chest of information, wouldn't it?
It would. And it could revolutionize our understanding of Mars and its potential for life.
Hmm.
Imagine finding fossilized microbes in those Martian rocks, proof that life once existed beyond Earth.
Yeah, that would be a monumental discovery, a paradigm shift in our understanding of the universe. But even if we don't find, direct evidence of life, just learning more about Mars helps us understand our own planet better, right?
Absolutely. Mars is like a mirror, reflecting back our own planet's history and evolution. By studying Mars, we gain insights into how Earth formed, how it's changed over time, and what factors have made it so hospitable to life.
So Mars exploration isn't just about space, it's about understanding our own origins, our place in the cosmos, and that delicate balance of conditions that make life possible.
Beautifully put. And let's not forget the technological advancements that come from pushing the boundaries of space exploration. Those innovations often have unexpected benefits back here on Earth, improving our lives in countless ways.
Right. Innovations in material science, robotics, computing, even medicine all stem from the challenges of exploring space. It's like a ripple effect spreading outwards and benefiting society as a whole.
That's the beauty of exploration. It's not just about discovering new worlds. It's about pushing the limits of human ingenuity, expanding our knowledge and inspiring future generations to reach for the stars.
So, as we wrap up our deep dive into the Mars exploration program, I have one final question for you, our listener.
Yeah.
Knowing what you now know about the challenges and the possibilities, what kind of experiment or technology would you send to Mars to search for signs of past life? Let us know. And keep exploring. The red planet is waiting.